Good morning, good afternoon, and depending on where you are, good night. Welcome to the 10 Principles of Apex Testing. I am Kevin Porman. I'm one of the principal architects at EDL Consulting, and you can reach me on Twitter if you have questions or you just want to follow up. If you want to follow me, whatever you'd like to do. Heckle, in fact, on Twitter, you can reach me at CodeFryer. We have the wonderful Safe Harbor slide. If you've never seen the Safe Harbor slide, congratulations. This is a Salesforce standard thing. You get to see this at the beginning of all the various presentations, especially Dreamforce. The idea here is that you should not purchase anything from Salesforce based on any forward-looking statements that I may make. I'm not planning on making any forward-looking statements, but just in case, you should only make purchasing decisions based on what Salesforce already has generally available. So this is a Salesforce developers webinar, and if you'd like to, you can follow on Twitter by following at Salesforce Devs or following the topic of Force webinar. You can also find Salesforce developers on Facebook, LinkedIn, YouTube, and Google+. And this webinar is being recorded, so when you want to, if you would like to pass it on to your friends and family who have not been able to make it, and you can also leave comments there on the YouTube as well. So if you have questions, feel free to ask them as you have them. I've got a crack team of QA people on the line, and they are going to be recording some questions and taking those down. We'll have a question and answer session here at the end. But if you'd like, you can ask the questions as soon as you have them there in the chat window. Please don't repeat the questions. The support team is going to work their way down the queue, so if somebody's already asked the question, just wait for it to be answered. It will be. And like I said, we'll have live QA at the end. If you have other questions that you would like to talk in depth on, you can post those on the developer forums there. The link is at developer.salesforce.com/forums. So for our agenda today, we're going to talk a little bit about why we do testing, and we're going to talk about the 10 principles of Apex testing, and then we're going to have our questions and answers. And if you don't ask questions, I will. That could be fun. But until then, let's start off talking about a little bit about why testing. So I was at my first software job, and I saw a sign very much like this. It said, "I don't always test my code, but when I do, it's in production." I thought I'd put it with the most interesting man in the world there to spice things up. But the idea about why we test is so that we avoid issues with production, so our clients, our customers never see those issues. So let's talk about a little bit about why we do testing. Tests give us a number of things, but they provide assurance of functionality, number one. This is our foremost reason we test. They tell us when our code works as we expect it to. Tests also reduce the cost of change. If you've got a nice test suite for a class and you need to go in and refactor the way that class works, you can refactor at will, knowing that if your tests still pass, then it's still functional, even though you've swapped out the algorithm or you've swapped out the way it works. So in the long run, tests help reduce the cost of change. They also encourage modular, reusable code. We'll talk about that here in a little bit more in depth, but the idea here is that smaller chunks of code that are reusable are easier to test. And so when you're writing your tests, if you come across a situation where something is a bit onerous to test, this is a way of knowing you might be able to write it better by doing it in a more modular, reusable way. Also, tests help us identify engineering and architectural issues. I wrote bugs there, but it's really more architectural issues and engineering bugs. As we're writing these tests and we're working through our test suites, we'll notice when things are hard to test. And whenever you run into a situation where you've got something that's hard to test, then you've likely discovered a flaw in the architecture or a flaw in the engineering and the way it's actually built out. And so when you're writing your tests for existing code, you may find opportunities to refactor that into more modular or reusable code. One of my favorite reasons for writing tests is that tests help document expected behavior. So if you've ever been the new developer on the team and you're trying to get ramped up on how everything works and where everything lives, tests help you identify that pretty quickly. By reading through the tests, you can see what data needs to go into a tested method, what that tested method is supposed to be doing by the output it produces, and you can see whether or not it works as intended by running the test. It's a great form of documentation. And lastly, and perhaps most importantly, tests and code work together in harmony to help you have fewer bugs. Now, what I mean by that is, if you just write a piece of code, you have a chance of having bugs. If you write some tests, you may have bugs in the tests, but if you have tests and code together, the chances of both of those having bugs are lower. So you're going to be able to ferret out different bugs and issues you have in your code by writing those tests and running them against your code. So that's a little bit on why we test. Let's dive into our first principle. The first principle of writing Apex testing is to use assertions. Now, there are three main assertion methods provided by Salesforce: system.assert, system.assert equals, and system.assert not equals. These three methods are the sort of low-level, most basic foundational assertions, and assertions are the bits of or lines of code you put in your tests to actually check to see that your response came back as you expected. So if you have a test and it doesn't have any assert methods in it, it's not really a test. It's just an execution of code. And that doesn't really help you with any of those benefits we talked about. It doesn't help you with learning how the code is functioning in terms of documentation. It doesn't help you form more modular, reusable code. It just runs the code. And while that will technically give you the code coverage metric Salesforce needs for you to deploy, it's not actually giving you any actual benefit. So we want to say, first principle, always use assertion methods. Every unit test method should include at least one assertion. Now, these three assertion methods that come with Salesforce all have a friendly message parameter. That friendly message parameter is optional, but this is really an opportunity for you to leave notes to yourself about what you were trying to accomplish in that test and what precisely failed in the test. So if you have a system.assert, something that returns true or false, and you're using the first one here, you can always put in a friendly expression of, I expected this method to return true, but it returned false with this input, and put in the input there. These help you when you're reading through a test failure to figure out what went wrong, where, and how to fix it. So like I said, every test method should have at least one assertion. And I want to point out that you can actually write your own assertion methods. This is a very handy tool to have in your toolbox. And the idea is you can write a class that has some custom assertion methods in it, and you can mark that class as test. It means that this will only be called in a test framework, but it also means it will not count against you in terms of code coverage. So you can write custom assertion methods. In this case, we have a duplicate account assertion, and it takes two accounts and it will compare them, and that custom compare can be customized to whatever you care about. So you can say, do they have the same address and the same set of contacts? Well, if so, they're duplicates and will return true. But it also has this throw new custom assertion exception, and it takes a friendly message. So this is where I'd put my friendly message in here. And when I run a test that takes this, if the duplicate accounts are not actually duplicate, it'll throw this custom assertion exception. And throwing an exception from within a method here will also cause the test class to fail. So this is how you can write your own assertion methods. This is a fairly basic one, but you can write complex things here, and it can really help make your tests more clear, because if you're using a custom assertion rather than 10 or 15 individual system.assert equals or system.assert not equals, you can clean those up and put them in an assertion method of your own. So that's it for number one. You want to use assertions. You want to make sure that your assertions are doing something useful. So you want to make sure that they're actually testing the output you're expecting from your tested method. So number two is related to number one. It's called use startTest and stopTest. Test.startTest and test.stopTest are methods that Salesforce has provided us to help facilitate testing. Now they individually they have to work together. So you're going to have a startTest method, and when you hit the startTest method, when the test framework hits it, it's going to reset your DML and CPU time and other governor limits. And that helps you make sure that if you're hitting a limit, if you're hitting a governor limit, it's coming from the code you're testing, not the setup of your test method. So if you need to create accounts or contacts or accounts, contacts, opportunities, and opportunity line items, and do all of those and make it to create your test data, those test data DML inserts aren't going to count against you if you're using startTest and stopTest. Likewise, stopTest has the ability to force asynchronous code to complete. So if you're writing tests and you're having a situation where you need to make like an asynchronous call for an at_future method, or you want to invoke a batch method, you can use the stop_test, and stop_test will force that asynchronous method, that at_future method, or that batch method to run before it returns from the stop_test method. So you can use the stop_test to make sure your at_future code is run before you assert against it. So when you're using startTest and stop_test, the general idea of, or the general pattern, is to create some test data for your whatever you need for your test method, and then you start the test using test.startTest. You use the test that you created, the test data you created just a second ago, within your tested method. You run test.stopTest and end the test, and then you write your assertions against the code that you got back from your tested method so that you can see whether or not it worked as expected. So that is startTest and stop_test. Assertions and startTest and stop_test are the base foundation of everything we're going to talk about here today, and you have to use those in every one of your unit tests in order for them to be well-functioning and useful unit tests to give you any of those benefits we talked about before. So number three is a type of unit test you want to write. You want to write positive tests. And positive tests test the expected behavior. So if you've got an addition method and it takes two integers and you want to add them together, when you write a positive test, you're going to say, when I run the add method with 1 and 2 as my parameters, I expect 3 to come back because 1 and 2 equals 3. So that's a fairly simple use case. In real life, oftentimes code, especially code that is from years back, will have multiple logic branches, if statements, else, if then else statements, and you'll end up having multiple expected behaviors coming out of a particular method depending on the data you put into it. So when you write a positive test, it's not just the happy path, it's not just the if everything is perfect with my input, I get back the expected output. But you're also testing or writing a unit test method for all of the different logic paths. So if you've got a logic path that checks for a negative integer in your addition method and does something different, like gives the absolute value addition, then you might want to, or you need to, write multiple unit tests so that you can test what happens when you put a positive test together for 1 plus 2, and you expect 3, and for also -1 plus 2, and you would expect 3 as well. So you need to have that conditional logic being tested as well. It's not just about the happy path or the simplest path. So let's look at what that might look like in terms of code. Here we have a basic class, and like I used in my example, we've got an add method, and it takes an integer, or 2 integers, and it returns the sum of those 2 integers. Fairly simple. Now, if we wanted to write a test for this, we could do the sort of the basic positive test, and we're going to have a test method here that's going to say test add positive, and we're going to instantiate our example code class that we had in the previous slide. We're going to run startTest. We're going to actually run the method we want to call or test in this situation, which is the add method. We're going to give it the parameters of 5 and 7. We're going to stop the test. And finally, when we're done with the test, when the test is stopped, then we're going to say the system assert equals, we expect the value 12. We're going to compare that against our test value that we returned from our tested method, and we're going to give it a friendly message. So this is about as basic as a positive test can be. And again, if we went over to the code again and we looked at this and made it a little bit more complex by adding in some ifs and elses there within our add method, we would want to test those as well. So the flip side of a positive test is what I call a negative test. A negative test prove that your code properly handles exceptions and errors that may occur when running, because you can't always assume that the data being sent to your method is pristine and you got to make sure that you've got positive integers, etc. The idea here is that you're going to write tests that check for exceptions being thrown and assert that a method exception was thrown. So the general pattern is to call your method within a try-catch block, and I'll show you some code that does this here in a second. And since you expect the exception, you'll catch that exception in the catch block, and you can then set a Boolean to true to make sure that you can assert against it later. These tests are less powerful, but in the end, these are the ones that help you catch bugs. They help you find edge cases where you didn't throw an exception, but you should have, or when an exception was thrown and you didn't expect it. These are very powerful and very useful. So here's an example of a negative test. We've got our example code method, or example code class, and we've got an example exception. So we've got an example code exception there. We've got, instead of the add method, we're going to use division, and we're going to take 2 integers in, and we're going to say if my second integer is 0, we want to throw an example code exception title and give it the message of dividing by 0 makes kittens cry. So if that is not the case, then we're just going to return 1 divided by 2. Now, so that's an example of a code we can test with a negative test here, and when we do that, it looks like this. So we've got a test method called test divide negative, and we're going to instantiate our example code class. We're going to create an exception, did catch proper exception, and set it to false. Now the reason we set it to false here is so that when we run our code in the try catch block, if that catch does catch a example code exception, we can set that to true and assert against it later. So here we're going to start our test again. We're going to try to call the divide method, and we're going to pass in 1 and 0. Now, as a developer who wrote the code, we know that this should throw the exception, so we'll call this within the try catch and try to catch the example code exception, awesome exception. If that happens, if we did catch an exception and that exception was of the type example code exception, then we'll set the did catch proper exception equal to true. When we stop our test and make an assertion, we can assert that did catch proper exception is true. That's how we write a negative test. We put our code that we know or we believe should cause an exception to occur within a try catch. We catch the kind of exception we're looking for, and if that exception comes back and it is of the type we're looking for, then we set something to true so that we can say yes, we caught it. Negative tests are incredibly powerful, and they're one of the 3 types of tests you should always be running. You want to always write positive tests, you always want to write negative tests, and you always want to write user tests. User tests are perhaps the most complex version of testing, and the idea behind a user test is that you want to prove out your security model, things that you've built out in your code base and in your org. You want to test with users of different roles, different profiles, and different permission sets. And when you're writing tests that are user tests, you're going to write both positive user tests and negative user tests. And the pattern works something like this. You're going to create a user, and you're going to create that user with a given profile. If needed, you're going to assign that user a given permission set, and then you're going to test that they can access data or that they should not be able to access data. So here's how that looks in terms of code. So we have a class here, our example code, and we've got an integer method getBankAccount, and that's going to take in an account and return the super secret bank account number. Now, as a user, some users are going to be able to access the super secret bank account number and some are not. And this method allows us to wrap that and determine whether or not we can see it. So as we look at our user tests, here's our example code. Now when we write a positive user test, here's how we do it. You'll see we'll still have the instantiation of our example code, and then right below it we have we create a user, and that user comes from awesome test lib get user with profile, and we're going to pass in the Jedi profile. Now that's a custom method in a custom test lib class that we'll talk about here in a little bit. But the idea here is you're going to have a method that returns a user. So that user will be able to will run the test as that user. So we'll create an account, and the account comes from a test factory, and again we'll talk about that here in a little bit. And finally here we're going to run the test as the user, and we do that with the system.runAs method. That's a Salesforce system class method that gives us the ability to run code as a given user, and we just pass in the user variable we've created. So in this situation we're going to create a user with a Jedi profile. We're going to run this test as the Jedi profile, and when we assert against the bottom, we're going to assert that the result is not null, because we expect the Jedi user profile to have access to the bank accounts. Now, on the flip side, everyone knows that the Sith are the bad guys, so we'll write a unit test that asserts that the Sith profile can't access the bank account number. Now, this is a very similar test. We're going to have the awesome test lib give us a Sith profile user, and we're going to create an account. And when we try to run the get bank account method, we're going to assert at the bottom that the result is equal to null, because the Sith Lord should not be able to access that value. Now, this is, again, these are simplified examples of what it means to do a user test with positive or negatively, but you can make them more complicated and more granular as you go along. As you write code and set up permissions in your org with permission sets, you can actually assign a given user, to have various permissions. So in this situation, a user test with a permission set, we're going to create a user the same way we did before, but we're going to pass in standard user as our profile name. We're going to then call a utility class that has a assign user to permission set method. We'll pass in the user and the can read bank account permission set name. And when we're done, we'll have a user that we can run the test as, and that user will have the permission set can read bank account. Now, we'll go into a little bit more about how the utility class portions of this work here in a little bit, but the idea here is you write a method that you can reuse over and over again within your tests to assign users to a given permission set. Now, when you run that as a system run as, the permission set will be applied, and in this situation, we're again asserting not equals that the result is null, because we expect users who have can read bank account to be able to read the bank account. So that's principle number 5 and the third general pattern of unit testing. We've got negative tests, positive tests, and user tests that are both positive and negative. You want to write both when you've got a situation where you're checking for permissions. So number 6, principle number 6 here is use your own data. If you've looked around in older code bases, you may have seen this this yellow bit here, @isTest see all data equals true. That gives the test the ability to read data from the database that pre-exists the creation of or the running of the test. You don't want to do that for a lot of reasons. You should normally not need to see all data true, but because you always want to build your own data, your own test data, and you can write this in such a way. You can build your test data in such a way that you don't need to see all data unless you're doing things with. The example that comes to mind is approval processes have to be tested with see all data, because you can't create an approval process in code. You have to do that through the UI. So unless you have to, you should never use isTest see all data equal true. Now, I want to bring up one other thing here. You can dynamically write your assertions. So if you're creating test data, you don't need to worry about creating a test account and then figuring out what its ID is or something like that in order to do an assertion. You can always take the data you created, the account you created, into a variable, say call it the account I created, and then reference its foo variable and compare that to the result account that you get back from your test method, your tested method. If you were testing something on accounts. The idea here being you don't necessarily have to write your test data to the database. In fact, if you don't write it to the database, your tests will run much faster. So when I talk about using your own test data, here's the general idea. You want to create your test data beforehand, and then you use startTest, and you'll run your tested method, and then you'll stop the test, and you can assert against what came back from your tested method against the data that you already created. So again, you don't necessarily have to put it into the database, and there are actually ways that you can make this much faster. So rather than writing helper methods to create an account or create a contact, you can actually use some pre-existing tools. There's one by Daniel Host that I find incredibly useful, and I use in just about all my projects. The link to it here is in yellow, the bit.ly link there. He's got this code. It's an open source class called testFactory, and testFactory provides 3 or 4 methods. The 3 that I find incredibly useful are the testFactory create S object, which is the second bullet point, I mean, and then there's one called create S object, but it also takes some parameters. So you can create if we look at the third bullet point, opportunity O, test factory create S object. You're going to tell it you want a new opportunity, but if you look there, you're seeing you can pass in an account ID based off an account you created on the line above. So you can, if you need to pass in custom data for your test to create the objects, you can do that easily here as well. And perhaps most useful, especially as you're creating bulk data, you can create a list up to 200 long of whatever your S object you want to create is. So in this case, we're doing new accounts, and a list will be a list of 200 accounts created for us. Now, the great part about Test Factory is it'll go through and populate the needed bits of information, and you can just call this, get an account, and move on. So I highly recommend this to you for making your own data and making your own data painlessly. And along those lines, to sort of help make using your own data more easy or easier, the other thing we can do is we can use a domain-specific test helper library. Now, earlier in the code examples, you saw something along the lines of test helper library, and those were static methods. And when the idea behind number 7 is that you want to create a library full of static test methods. You want to mark it as @test so that you're sure that your code there within it is never called by live running code in production. And then you can that also helps ensure that it won't be counted against you in your code coverage. But the idea here is you're going to create a bunch of static helper methods to create data or to help your tests run faster or to be built faster. And what I mean by that, and so there are some candidates that come to mind for what you could automate this way, and that's the idea of like creating a user object and automatically assigning it a given permission set. So you might create a method that says, get me a user, account or a testing library dot get user with permission set Jedi, and that would return to you a user who already had the Jedi permission set applied to it. So instead of just getting a user from, say, the test factory that Daniel provides, you could get one here that you customize with various permission sets. You can also use this as a sort of a place to build composition methods. So if you need to grab a complex object tree for your test, say you need an account with 5 opportunities and each opportunity has to have 3 products on it, you can create a method called generate account with opportunity and products and have that call the test factory the correct number of times to provide you an account, and then attach opportunities to that account and attach products to those opportunities. So you can call one method, have it roll this all up, and give it back to you. Another sort of candidate for test helpers include anything you have to do more than once in a test suite. So this there's a fine line between sort of test setup and teardown methods that you run before and after each of your test methods, but this is more along the lines of if you ever have to set up a custom setting or something like that, you would want to create a custom setting creation helper within your library to do that. I also recommend that everyone use a naming convention with their test libraries. So this is the one I use. I have generate methods, and those generate methods return an S object. So I can have generate account, and it'll give me back an account. Generally, I also make those generate methods take one parameter. That parameter is a do insert. It's a Boolean. If do insert is true, then it will insert in the database. Otherwise, it just gives me back the S object it created. And then I also have some get methods. Those get methods retrieve an object via sockle. So if I want to do some testing on an account and how that account is changed by a method, then I can use my get methods to retrieve the standard field sets that I'm going to be working with instead of typing them all in my test code. So that's number 7, use domain-specific test helpers. This combined with number 6, the using of the test factory, makes creating your own test data insanely simple and very quick. It takes a little bit to learn how to use, but once you've done it a couple of times, you're off to the races. You'll be able to start building out some custom helper methods, and those helper methods can call factory methods to get S objects back, and you're golden. It is a big help. So that's number 7 here. Now, when we switch to number 8, we're really diving into the deep end of testing. This is number 8 is mocking. You want to use mocking wherever you can. The idea behind mocking is that you're actually drawing a distinction between an integration test and a unit test. So It turns out what we call unit tests in the Salesforce world are actually usually much more than unit tests. They're usually integration tests. And what I mean by that is it's hard to test a given bit of code by itself without also spinning up a whole bunch of other things. So for instance, if you've got a bit of code that you want to test that's testing some function of an account, you need an account. But that also means you're going to have to run triggers, etc., to get that account inserted into the database. So what we do when we talk about unit tests versus integration tests, a unit test is going to focus on a single unit of code, a single bit of logic, not necessarily even a complete function. We're going to narrow down and look at a specific logic path. Now, mocks allow us to do this, and they are specific types of objects, and what they do is they allow us to mock or create a fake object. And when we create that fake object, that mock object, we get to set up its methods and override them so that we are assured of, given X input, what the response will be. This helps us, especially when you're doing things like making a call out to an external service, or doing a call out to even an internal service layer object and methods. You can mock those service layer objects or mock the call out objects so that you don't actually have to make the call out and you don't actually have to worry about the implementation of the service layer object. So mocks are very powerful, and what they allow us to do is something like this. So first off, let's talk about the traditional integration testing model. We've got a unit test that we've written, and our unit test is going to call a service. And because we don't know what the implementation of that service is, we don't know what the response will be. Now, why do I say we don't know what the implementation is? That implementation may change. We may be writing a bit of code and tests that test a controller for Visualforce, for instance, that relies on a bit from a service layer object, and that service layer object may change its implementation. Generally, we want to avoid having our tests be dependent on external bits of code from the actual controller that we're testing. So in this situation, we have a test that could fail or pass depending on what that service call returns. So in the flip side of that is we have mocking, and what we do with a mock is we create a unit test, and we have that unit test create a mock object. And because that mock object has faked out or mocked methods, we can say when a method is called with these two parameters, these 4 parameters, return this given result without actually running that service object's code. It allows us to short circuit running the actual service layer code. It makes our tests faster, and it allows us to guarantee what the result will be for services that are not critical to the code we're testing. So in this situation, our known results are going to get passed back into our unit test from the mock object when we call the appropriate method. So here's when we want to use mocks. We want to use mocks whenever you're going to that object is not critical to the test. So if you've got a bit of code and that code is calling a service layer object or making a call out, you want to replace that result object that it gives you back with a mock object and mock out the service layer object or the call out object so that you can get a consistent known pattern of data. So if you're going to populate an account with the results of a web service, you're going to mock out the web service result. And that allows you to say, okay, well, I don't really care what the web service responds with. I just want to test that my code is able to properly parse, as I understand it, the results back from the web service. So you'll pass in the results you want it to return, and then the mock will give you those results and only those results. And this allows you to also bypass making callouts altogether when you're doing callouts and that sort of work. When I say that they're not just for web services, we can mock things other than the web service. I've mentioned service layer objects. If you're using enterprise patterns, you may have service layer objects. You may be familiar with that idea. But really, we can mock anything where we want to assure the given result is the same so that the test can handle or prove that it handles the result properly rather than testing that the result comes back. All right, so you get to write interfaces and code to the interface when you're using mocks, and I'm going to give some example code on how to use this mocks, but mocking is a whole webinar unto itself, and there's actually a really great presentation by Jesse Altman I'm going to link to here in just a little bit, and he's got a whole basically an hour-long presentation on how to use mocks, and I encourage you to read up on that, to go watch that presentation. So here's some example code on mocking. And this is sort of the mechanics of it, how we do what we're going to do. So if you look here, we have got our example code tests class, and we have one test method, the mock example. It takes 2 accounts as parameters, and then the first 5 lines or so is actually creating the mock object and specifying what we want it to happen. So if you look here, we're going to create an Apex mocks object M, and we're going to pass in an interface name to mock. So we're going to have a service that is mocked out. We're going to start stubbing, and when we start stubbing, this is what allows us to say when you call a method with given parameters, always return the following result. So in this situation, if you see the m.when mock.add, so our mock object.add 5 and 7 as parameters, then always return 12. So all of that just sets up the mocking and the stubbing. And when we actually go to run our test here in the startTest and stopTest section, you'll see that it calls our example code, and it tests that it gets the result back by calling mockObject.add 5 and 7, which is exactly what we stubbed out, so we know that it will return 12. So in this situation, we've got it set to assert equals 12, and compare that to our result, and give us a friendly message back if it fails. So that's sort of the basics of mocking. Mocking has the ability. So this is, let me back up. This is mocking objects other than HTTP callouts. You can also mock out your HTTP callouts, and you do this by mocking HTTP responses. This allows you to run a test, and instead of actually making an HTTP callout or trying to, which will fail because you can't do a callout during a test, you'll get back the results that you specify. So the Salesforce platform has provided us a interface that we can code to that will return an HTTP response object. And what we do is we just need to create that response object and set it up so that it's given back to us in testing. Here's what that looks like. I use a factory to create my mock callouts, and you'll see here I've got a it implements the HTTP callout mock interface, and then we've got a constructor here that takes in some an integer for the code. That's going to be like a 201 or a 404, a string that's the status, like OK or permission denied, and a string of the body, what we want to be returned to us as the body, and then a string of response headers. So once that's done, we've got this method that we have to put in there for the interface called respond. And it's going to take a request. That request is the request we call out with. And then we're going to create a new response. We're going to set the status code, the status, and the body to the bits of code that we created, that we passed into our constructor. Now, why do I use a constructor for this? Because you can extend your constructor and extend this pattern to return different responses based on a static class variable. So you can have multiple callouts, and oftentimes you'll have chained callouts. Go get some data from web service A and then pass that into web service B and get some data. And you can use this and the constructor pattern by just creating an additional constructor that accepts a list of JSON strings that deserialize into responses. So you have one constructor, you set that up in your test. Here's my 4 responses, go for it, and then you set up your class there, to the mock, to return object 1, object 2, object 3, and object 4. That's sort of the basics of mocking HTTP callouts. This is a great way, so you don't have to do like is test, return 200, blah, blah, blah. This allows you to mock out your result. All right, moving right along to number 9, write for testing. The idea here is you want to write small, tightly focused methods that play well with others. So you're going to write a bunch of methods, more than you think you probably need on objects. You're going to then compose advanced functionality by using the small objects together, the small methods together. So if you need And a great example of what I mean by this is the idea we talked about with the test helper library, where you need an account with 3 opportunities, and each of those having 10 product line items on them. You can create a method saying get account with objects and line items, and that would be a method that largely called other methods, saying get account to the test factory, and then give me 3 opportunities with that account ID, and for each of those opportunities create product line items X, Y, and Z. So basically your get account with opportunities and line items is a method that is composed of other small methods being run. Now, why you do this? You can, when you write smaller methods like this that are very focused and have a easily definable result set, you're able to write more or less unit tests without having to mock. And you write those unit tests to work on your focused methods. You get your code coverage and your testing, positive, negative, and user testing based on a get account method that just returns an account, or that sort of very small, tightly focused method. And then you can integrate tests and do your integration tests by writing and tests on your composed methods. Now that's a whole lot of great computer science theory, but what does it mean to actually do that in practice? So I was thinking about this a while back, and I put together some guidelines on writing for testing. So as you're writing your code and you want to make sure that you're writing this to be easily testable, try to keep your methods to no more than 20 lines. Now that is an awfully short method. You have to be very focused in what you're doing with a method that short. But that's good, because once you've got a method that's only 20 lines long, it becomes pretty easy to test that, even positively, negatively, and with users. You want to keep your arguments to a minimum, no more than 4. If your method takes more than 4 arguments, then you're going to have a problem getting it under 20 lines. Just dealing with the parameters. But if you keep your methods to a minimum, your arguments to a minimum, when you're writing these tests, it's pretty easy to, even if you need to mock something, it's pretty easy to inject a mocked object into that method call and test it pretty easily. And perhaps most controversial, the last one here is write your Visualforce controllers to use a single wrapper object. And what I mean by that is your Visualforce controller should only expose to the page one object. Now that object is going to be a wrapper, and you're going to be able to inject other objects into it. You're going to be able to put custom methods on that object, etc. But make sure that that one wrapper object is exposed to the Visualforce page. And by doing that, you'll be able to test the logic of the wrapper object rather than the complete logic of your controller separately. So you'll be able to do something like create your small, tightly focused methods on your mock object, test those, and then as you need to, test the composed methods from the controller itself in terms of controller logic, but only thing that's exposed to the Visualforce page is that single wrapper object. But that also means that you can write a test helper method to create that single wrapper object, or you can use a mock to put in there as well. And the last one that I want to point out is you want to use descriptive method names. If you're writing lots of small, tightly focused methods so that you can easily test, you're going to want to have descriptive methods to them. So you don't want methods like get an account with options. You want get account with opportunity, 3 opportunities, or n opportunities, and n opportunity line items. You want to be able to read that method name and know exactly what it's doing. And the same goes for your tests. When you're writing your tests, you want to be able to say, okay, this is a test that tests method X positively, or tests method X negatively, or tests method X with the 3 following users. So maybe standard user, sysadmin, and user with elevated permission set. So that's the sort of some writing for testing guidelines. But again, the idea is that you want to write small methods and compose those into more detailed logic methods, and move on from there. So you can test the individual units, the individual methods, and then test your complex logic based off the composition of those smaller methods. And lastly, the last principle is use continuous integration. Continuous integration is the idea that every time somebody commits a change to your code base, the source repository will trigger a full run of the tests. Now, I say a full run of the tests. I have a friend of mine, he works for a very large company. Running all of the tests in his org takes 14 hours. So perhaps you don't run it every time somebody changes the code, but you might do it every day, and you want to do this for a number of reasons. It's going to help give you visibility into your failing tests and and visibility into your code coverage. How do you do CI on the Force.com platform? There are a number of tools available. There's Travis CI, there's Drone.io, the venerable old Jenkins, and one called CodeShip are some tools that you can use for CI. The LA user group just had a great presentation on CI, and I'm looking for a link to that, and I'll post it as soon as I can, as soon as I find it, all about using some of these tools and how to do it. Again, why would you want to use continuous integration? It's going to give you insight into failing tests as soon as they're committed, so you'll know that you've got a test that's failing before you try to do a deploy. It's going to help facilitate the idea that multiple developers are working on the same project by letting them work in their own sandboxes or dev orgs. And then when they commit their code, it commits through a pull request on GitHub or Bitbucket, the ability for your integration org to pull in their code and their tests, run all the tests, and prove that by committing that bit of code, they haven't broken anything, or they haven't created a problem for another set of tests. And again, it's going to keep you aware of your code coverage. They'll all kick back the amount of code coverage you get. And so with that, I just have a couple of useful tips here. Don't insert or query unless you have to. You can often run your tests with just objects in memory. That's a big helpful time saver. So if you don't need to insert because you don't need an ID or something like that, don't insert, just use it in memory. You can learn more about mocking. This is the link here to the introduction to mocking that he gives, that Jesse Altman gives. It's totally worth your time. It's about 45 minutes to an hour long, and I encourage everyone to review that presentation. And lastly, I want to encourage everyone to use a standardized logging library that highlights what you're trying to log in the log with a nice visible header and footer. I tend to use a row of asterisks, an 80-character row of asterisks as a header and footer, so I can easily see as I'm scrolling through the log what is system generated and what I generated in terms of logs. That's very helpful. And with that, let's see here what we got. We have the last bit is Trailhead. I want to encourage everyone to go visit Trailhead. If you've never used Trailhead, it is a fantastic tool for learning all kinds of information about Salesforce. But one of the things they've got is the Apex testing badge, and so you can go to Trailhead at developer.salesforce.com/trailhead and work through the Apex testing trail, and when you're done, you'll get a nice orange badge with a little bug on it for the Apex testing badge. And with that, I think what we're going to do is I'm going to put this up here. We'd love your feedback. This is a feedback survey link. And we'll make sure that that's pasted in the chat as well, because the other thing that I want to do is point out a couple other webinars that are coming up. We're going to have powerful new API enhancements in Summer 15. If you've not read through the Summer 15 release notes, be excited. This is going to be awesome. There's going to be a webinar on that on June 4th. And if you are available, June 16th through 18th in New York City, there's going to be the World Tour, and Salesforce developers will be there in the Developer Zone in the World Tour. So you can stop by there. And with those announcements, let's turn it over to Q&A, and we'll see what we can do in terms of answering questions.
So the first question was when to give and not give CL data equals true in the test class, and this is kind of a popular theme across some of the questions here. And one of my answer was basically it should only be used in the very rare case where Salesforce functionality requires it. It used to be a staple for like price books and standard price books and price lists, but that was fixed a couple of releases ago. So really, in a perfect world, CL data equals true should never be used. Instead, you should create your own data using mock data or the mock library that Kevin pointed out.
Awesome. one other example of when you might have to use CL data is if you are testing an approval process. So if you've written some code to automatically approve a record once it's entered an approval process, that kind of test will require CL data. The next question we have is, one trend is moving some of the functionality into JavaScript in the Visualforce page. What are your recommendations to test that that JavaScript code? That's actually one of my passions. I do a lot with AngularJS on top of Visualforce. I found that you can write your JavaScript tests using whatever framework you'd like, whether that's I use Jasmine, so you can write your Jasmine tests, and then I hook that into continuous integration. I tend to use Drone.io, and it allows me to test both JavaScript tests and my Apex tests at the same time. So once you've set up your tests, you can either run them by, like Jasmine, you can embed the Jasmine test runner inside of a Visualforce page, so you just load that Visualforce page and you see all your tests run, or you can hook that into continuous integration and see that run anytime you change some of your code. Let's see, the next one we have is, are the limits or governor for assert methods used in a test? James, back me up on this one. I'm not aware of any governor limits regarding the number of asserts you can use.
Yeah, that's kind of how I envision it too. So in terms of the number of assertions that you can use, there's no limit that I know of or Kevin knows of, I guess. What I put, or my stance on it, is basically the more the merrier. So the more assertions that you have, the merrier. And what else did I say here? Let's see. And I kind of answered this too. So governor limits do apply to the test case itself, which brings in it's always a good idea to use the test startTest and test stopTest methods to go around the governor limits for the test class itself.
And that's sort of one of the key features of startTest and stopTest. The next question is a really good one. Someone asked, if a trigger is written as a single line trigger pointing to a dispatcher class, pointing to a potentially asynchronous function specific class, how do you write an Apex test with sufficient coverage? So interestingly enough, every class must have 75% code coverage, and every trigger must have some code coverage. So the way I tackle it,
actually, the overall code coverage is 75%. A class
doesn't
really need 75% itself.
Thank you for that. That's true. You have to have 75% code coverage aggregate in order to deploy, but your test classes, your triggers all have to have some test coverage. So when I come into a situation like this, and I agree, this is writing a single line trigger that points to a dispatcher class is definitely the way I write my triggers. When I do that, I tend to write tests for my dispatcher class because I can create a list of original objects and a list of updated objects, and then pass those into my dispatcher class outside of the trigger reference. And I can test the dispatch class that way, and then all my other classes, like a function-specific class that may or may not be asynchronous, are tested individually as well. So the idea here is almost a test profile. So you're going to write a test or series of tests for your dispatcher and a series of tests for your function-specific class. And then finally, somewhere in there, throw in a test that actually invokes it through a trigger context.
Yep. I would also argue that maybe you want a separate class for the trigger itself as well.
That's
just
true.
To create or update those records to fire that trigger to cover that. The non-zero code coverage for the trigger itself.
It's a good call.
And you really can't go wrong with the more, in general, I try to stick to a minimalistic approach with general Apex, but with your unit tests, really the more the merrier. And if you cover code across multiple unit test classes, it really doesn't hurt anything to do that way. So the more test classes, the better.
More tests, more better.
Yes. Yay, grammar.
Another question we have here is, can a test method have more than one set of start test or stop test? No, you can only have one start test and one stop test call. The solution to that is to create multiple tests that test the same code. The idea or the situation that I most often run into Where I want to have more than one start test and stop test is where I'm trying to test a method that has multiple different outcomes based off of branching logic, and I want to be able to, pass in a different set of parameters to the method for one situation and not another. And the solution there is just to have one expected outcome tested per test. So let's see
Yeah,
here.
another thing too here is once you call that start test method, that's what actually resets your governor limits for your unit test. So maybe there's a particularly function a heavy approach or something in your code, and so maybe you want to break out your unit test to cover one part of the code and then in one unit test, and then another part of the code in the second unit test.
Somebody asked about performance hits or performance overhead issues with multiple assertions within the test method. I find that I don't generally run into performance problems with my tests unless I'm writing a whole bunch of stuff to the database and reading it from the database. So if you're doing a lot of DML within your tests, then you might hit a performance issue, but generally it's not the assertions that are going to be causing it. They're generally very quick checks. Do these two things equal or not equal, or is this true? So I don't think I'd be worried about the performance overhead. I
Yeah,
don't
the only
actually
thing I
know of
could
a good
think
way
of
of
is like,
measuring it.
yeah, the only thing I can think of is like looping through, a huge result set and doing a bunch of system asserts inside the for loop or something like that. But
That's
in
true.
general, it shouldn't really impact performance. And again, the more assertions, the merrier.
Good deal. Um,
It may slow down your deployments a little bit, but I can't picture it taking too long, for a single unit test.
Somebody else asked about running system.runAs in a test class and whether or not that's a best practice. I'm always leery of giving something the title of a best practice. I will say that it is the best idea I've come across to use run as. Let's see here. How can you add to a permission set and
In particular, sorry, on the system run as piece, in particular, it's a good idea, so to speak, to use when you're testing record visibility for any Apex that uses the with sharing keyword. So you're testing that the org defaults or whatever record visibility using the system.run as.
Yeah, that's the only way to trigger uh, because tests normally run in sort of a system context. They sort of ignore you know the settings you may have in place for record visibility, etc. The way to get around that is to use system run as and then pass in a user that you want the code to run as. That's the only way to actually test outside of a system context. Let's see. So somebody asked about see all data equals true might reduce our efforts to create test data, so why not use it? First and foremost, when you deploy tests from a sandbox to production, you can't guarantee that the record, or from one org to another, you can't guarantee that the record you're expecting to be there is actually there. So you may run into deploy time problems where you test pass in a sandbox or at a dev org, but they don't pass in production. And that's because you don't have an org, you don't have a record with the same ID or a record with the same name, however you're querying for it, it may not be there. So you should always create your own test data, even so that when you deploy from one org to another, that test data is created on the fly so that the tests pass instead of potentially failing due to data not being there. Lana, how are we doing on time?
Unfortunately, I think we may have time for one more question.
Looks like we're about 2 minutes over.
Yeah.
One more question. Okay. Let's see here. Somebody asked about using @testSetup. @testSetup is an annotation you can put on a method, and that will cause that method to be fired before each of your test methods. It allows you to set up some data, and if you are dealing with a relatively simple amount of data, or you're calling your helper methods that you've created to populate a data tree or an object tree for all the data you need, test_setup is a great way to do that. The alternative is to just directly call your helper method from within your test method. The flip side is you may end up having more DML, for instance, within your test method rather than outside of it. So I think we've had some great questions here. If you, like I said, if you've got more questions, go feel free to ask them in the developer forums at developer.salesforce.com/forums. Again, this is being recorded, so you'll be able to view it on YouTube and talk about it with your friends and coworkers. And I think that's a wrap.